Hello, you're on Pablo Spot. I'm George. Welcome to a new episode on this series on setting up load balancer infrastructure. And today, I will be exploring how to integrate AWS Application Load Balancers with Lambda Functions. And so if this series and the content of this channel lines up with your interests, hit the subscribe button and join me in this journey of learning by doing. So, let's start coding. Today, we are going serverless with my load balancer setup, and what I will do is configure a new target group that will allow forwarding of web requests from my application load balancer to a Lambda function. But before I start doing any work, let's quickly talk about the benefits of going this route of implementation. In the previous episode, I have set up my Nginx application that is running on EC2 instance accessible through my application load balancer. The thing with this setup is that I need to make sure that my EC2 instance is well managed, apart from making sure that my web application runs properly inside the EC2 instance. The benefit of having the application run through Lambda function is that we can worry about just the application that we want to be accessed through a load balancer. And because the low-level infrastructure that the application runs on is maintained by AWS, we don't have to necessarily worry about the server maintenance, which could range from making sure that the server is hardened and it has the latest operating system patches, to making sure that the capacity allocated can cope with the application demands. This means you save yourself from worrying about the operating system and focus more on making sure that the application works as expected. On one hand, what are the trade-offs for using this kind of implementation, having an application load balancer talking to a Lambda function? AWS Lambda Function has a number of trade-offs, but the ones that many people talk about include the 15-minute runtime limit for Lambda functions. However, you would not really want to architect a web application that runs longer than a minute. Otherwise, this will have an adverse effect on the user experience on your website. And speaking of the length of time that a web application responds to requests, one of the biggest trade-offs for Lambda functions is its cold starts. In a serverless architecture, we need to account for the time a server starts up before the application starts running. And this is when we start to look for ways of keeping the server behind a serverless architecture persist. Very common implementation to address this include setting up a keep alive mechanism that involves some kind of a regular polling or pinging to make it look as if the server is still receiving requests. The other trade-off with Lambda function is the size of the deployment package. When you start writing your code, there will be dependencies that need to be accounted for, and the size of the deployment package affects the time it takes for the application to completely load up and be ready to accept requests. This would be something to look out for, and what you need to do is ensure that the right control and minimization of dependencies are in place. Now let's get to work. I'm going to make my implementation as simple as possible. So I'm going to start by creating my simple Lambda function in Python. I'll create a new directory in the root of my repository and call it Lambda scripts. And then inside this new directory, I'll create my file called lambda.py. What I want to do is render an HTML page when the request is forwarded to my Lambda function. What this Lambda function will do is simply return an HTML document that will contain a string to show that the call was made to the Lambda function. And now, I will start writing the necessary infrastructure code to push my Lambda function into AWS. So I'll start with setting up the archived file that will compress my script. So on my data.tf, I will set up an archive file block. I am going to set the type property to zip. And set the source file property to point to the location of my Python script. And then I also need to add an output path property to an arbitrary zip file name. Now that I have my compressed script ready to be deployed, I will head to my main.tf and start writing all the necessary resources to configure my Lambda function. I'll start with the actual Lambda function resource, so all the way to the end of this file. I will set the basic properties for this Lambda function, starting with the function name. I will also set the runtime property. I use Python, so I will set this property accordingly. And then I will need to set the timeout property and set this to 30 seconds. I need to set up role property to this Lambda function for it to be recognized as a Lambda service. This role property needs to point to a new IAM role resource. So at the end of this file, I will create a new IAM role resource. I am going to set the basic name and description properties for this resource. And this role also needs an assume role policy, which will define what service this resource will assume. I will set the value of this property to a JSON encoded value of a standard AWS policy document. I will set the service property inside the JSON encoded policy document to the appropriate value for a Lambda service. Now back to my Lambda function resource. I can then update the role property to point to the new IAM role. The Lambda function resource also needs a file name property that needs to point to the zip file that is created by the archive file data reference that I created previously. I also need to set a handler property that will point to the actual Python script file name and the method name. And lastly, I need to set the source code hash property to point to the output base64 SHA-256 property of the data archive file. And that's my Lambda function. What I need to do next is set up the resources that will bridge my Lambda function with my load balancer. And because I'm setting up a new target type, which is Lambda, I will create a new load balancer target group resource. I will set the basic name property for this resource. And because this is intended to target my Lambda function, I will set the target group property to Lambda. And what I need to do next is create a new resource to attach my Lambda function to the target group. This resource needs a target group ARN, which needs to point to the Lambda target group resource that I've just created above it. This resource also needs a target ID property, which needs to point to the ARN of my actual Lambda function resource. Having only this setup will not work because by default, my target group resource does not have the necessary permission to talk to my Lambda function. So what I need to do is create a Lambda permission resource. So all the way to the end of this file, and on this resource, I will set a statement ID property, which is an arbitrary identification string for this resource. I also need to set the principal property, which needs to have a value that points to the principal resource that will talk to my Lambda function. In this case, this needs to be the appropriate principal service string that applies for load balancing. The next property to set inside this resource is the action property. This determines the permission that the load balancer will have. And I want my load balancer to be able to invoke my Lambda function, and so I will set this property like this. I also need to add the function name property, which I will point to my Lambda function ARN. And lastly, I need to add the source ARN property, which I will point to the resource that will directly invoke my Lambda function. And in this case, this property needs to point to my target group resource. Now, I want to make sure that the Lambda permission resource is created first before I associate my Lambda function with my target group. And so, back to my attachment resource. right here. What I need to do is add a depends on property to allow the Lambda permission resource to be created first before my attachment resource. And the final piece of the puzzle is setting up a listener rule resource that will eventually forward the request to my new target group resource for my Lambda function. And so at the end of this file, I am going to create a new AWS LB listener rule. I will set the listener ARN property for this resource to point to my pre-existing load balancer. And then I will add an action block. And this action block will have a type property with a value forward. And a target group ARN property that will point to the new target group I created for my Lambda function. I also need to add the condition block, which will be evaluated before the request is forwarded. I want my Lambda function to be called based on a path pattern. And I want to make sure that the route is Lambda. So I'll update the values property and add /lambda in the values. And that's it. Now let me switch to my VS Code terminal and start updating my infrastructure. I'll start with exporting my TF workspace environment variable as usual. And then export my AWS credentials on my session through AWS Vault. And then start running Terraform init. And then Terraform plan. And then run Terraform apply. Now that the apply is successful, let me switch to my browser and verify my changes. And if I go ahead and access my endpoint with /lambda at the end, the web request forwarding is not working properly and it takes me to google.com. This is not what I'm expecting. So let me switch back to my VS Code to fix this. The issue here is that my Google redirect is evaluated first before my Lambda function rule. So what I can do to quickly rectify this is update all my listener rule resources and add a new property called priority. This priority will determine the order of when the listener rules are evaluated with the lowest number being the first. I have 4 listener rules. So with my new Lambda function rule right here, I will set the priority to 10. And now let me head to my fixed response rule. Which is right here, and set the priority to 20. And then I'm going to head to my redirect rule, which is right here, and set the priority to 30. And lastly, my nginx rule can be set to a priority of 40. Now let me head to my VS Code terminal and update my infrastructure. Now let me switch back to my browser and then attempt to access my Lambda endpoint. This is a message that I've set inside my Python script, so it works. However, if I try to access this same route or path using the public DNS of my load balancer, that also works, and that's not right. So let's fix this. Let me switch back to my VS Code. And let me head back to my listener rule for my Lambda function. What I need to do to protect this particular listener rule is to add another condition to validate my host header. And I want to ensure that the value has my url.publicspot.ml. This will ensure that only web requests with this host header will flow through my Lambda function. So now let me switch back to my VS Code terminal and update my infrastructure. Now, let me switch back to my browser and attempt to access my Lambda function through my load balancer public DNS. So I'm going to refresh this page. And now that gives me an unauthorized message, which is what I want. And that's all I have for today. Stay tuned as I continue to explore better ways of implementing infrastructure code for load balancers. In the meantime, let me know your thoughts in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning and stay safe. See ya.